lesson about prime factorization, lesson 9-2 from last week, because there was a little bit of confusion from some people. So we just want to work on this and make sure we have it down. So the first thing I want to show you is that I did make an info sheet for you that contains the divisibility rules and prime numbers under 100. So remember, the divisibility rules are just rules that let you know whether or not 2, 3, 4, 5, 6, 8, 9, or 10 can divide evenly into a number. And then with the prime numbers, here are all the prime numbers that are between 1 and 100. So notice it starts with 2, because that's the first prime number, and the last one's 97. Okay, so these you can print out or you can just have open on your screen with you whenever you're doing work, because these can be helpful for doing lesson 9-2. So the first part of 9-2 was just listing all of the factors that make a number. So we're going to look at 63 right now. Okay, so I'm going to work through and think of all the ways to make 63. Well, the first way is always 1 times the number. Okay, and now we're going to go through our divisibility rules and see if anything else can make 63. So 2 goes into anything that's even. I'm looking right over here at this, the divisibility rules. So 2 goes into anything that's even. 63 is odd because 63 ends with a 3. So 2 does not go into it. Now let's check for the divisibility rule for 3. The divisibility rule for 3 says 3 goes into anything whose digits add to a multiple of 3. So that means let's add these two numbers together. So 6 plus 3 is equal to 9. And then I ask myself, okay, does 3 go into 9? And the answer is yes, it does. So 3 does make 63. So the question is 3 times what? Well, to figure that out, you just do a little quick dividing. 63 divided by 3 would be 2 times to make 6. Drop down to 3. And 3 into 3 goes 1 time. So this is 3 times 21. Okay, and I'm just going to delete that real quick to make some room. Okay, so I move on to the next rule. The next rule is 4. It has to be even first, and 63 is not even, so that doesn't work. Go on to 5. 5 goes to anything that ends with a 5 or a 0. 63 does not end with a 5 or 0. Next, I check 6. For 6 to go into it, 2 and 3 both have to go into the number. 3 goes into 63, but 2 does not, so that means 6 does not. Now we check for 8. 8, again, it says it has to be even, so right away it doesn't work. And 9's rule sounds just like 3's rule, except when it adds up, it has to be a multiple of 9. And if you remember, we did 6 plus 3, and that equals 9. I asked myself, can 9 go into 9? And it can. And I remember that this is times 7 from my multiplication facts. So again, I'm just going to delete that out. And I check for 10. 10 doesn't go in. So I'm looking and I'm thinking that this is about the only ways that we can make it. So these are all of the factors over here. Right here are all of the factors. But the assignments inside the book and everything wanted us to put these in order from least to greatest. So the way that we do that is with the rainbow method. So the first thing you do is you take the 1 times the number. And you do 1 and you rainbow connect it with the 63. This loop that I just put over top of them is saying that those two work together. Now I'm going to grab a different color to make this kind of rainbowish. I'm going to connect 3 and 21. So 3, and that's going to connect with 21. Again, I'm going to pick another color real quick. And I'm going to do the 9 and the 7. Well, I'm going to do 7 first because it's least to greatest. 7 and 9, and that connects right there. So if I put a comma between all these, there are all of the factors from least to greatest that make 63. Okay, a lot of folks were good with this, so I don't want to spend too much time on this. Let's go into the factor trees and ladders. That's where I saw the most confusion happening. Okay, this is the reason why I gave you the prime numbers on the bottom of the info sheet list. Because when we are working with this, all of these bubbles here that do not branch apart need to be prime numbers. Those are the only things that you're allowed to put in there are prime numbers. So I always like to start with the smallest prime numbers and then work my way up with divisibility rules to see if they can make the number that's above them. So the first prime number is 2, and I look at 105. Definitely can't do 105 with a 2. Now, I also notice right away that it ends with a 5. So actually, we're not going to do from smallest to biggest because that's such an obvious thing right there with that 5 at the end of it. So we're going to do the 5. So the question is 5 times what makes the 105? Well, if we don't know that, then we should come over and do a little division. 5 doesn't fit into 1, but 5 does fit into 10 twice, which makes 10. Drop down, and I get a 5. 5 fits into 5 one time, and that gives me my remainder of 0. So 21 times. So like we said, that divisibility rule for 5 makes it a lot faster for us to decide what goes into it. Okay, next I am going to now look at the 21. It's not even, so I can't divide it by 2. But I can divide it by 3 because 2 plus 1 is 3. 3 goes into 3. So I can use 3 right here because 3 is a prime number. It's on my list. And then I know from my math facts that 3 times 7 makes 21. Okay, so what I've done right there is I've now found all of the prime numbers that make 105. And those prime numbers are 3, 7, and 5. 21 is not a prime number. It's not on my list. So when I make my prime factorization, I cannot use 21 or 105 because they are not prime numbers. And besides for not being on the list, I know they're not prime numbers because they branch apart. So when I write my prime factorization for 105, I like to go in number order from least to greatest. So my smallest prime number that worked here was 3 times 5 times 7. And if you're ever wondering if you did it right, all you have to do is multiply those 3 numbers together. 3 times 5 equals 15, and then 15 times 7 actually does equal 105. You can check on a calculator if you don't believe me. But this right here is the prime factorization. Let's understand the difference. The prime factorization is the multiplication problem. This section over here that I'm circling right now, that's called the factor tree. That helps me to find the prime factorization. It's not actually the prime factorization. The prime factorization is this final answer that we get after we do the factor tree. Okay? So let's do one more together. Let's look at 198. So when I look at 198, I automatically see that it ends with an 8, which is an even number. So I look at my prime list and I know 2 is the smallest prime and it always goes into even numbers. So I'm going to do 2 times something to make 198. Again, if I can't figure it out or I don't know it, divide it. 2 doesn't fit into 1. It fits into 19 9 times, which is equal to 18. That's what 9 2s are. I subtract, I get 1. I drop down. I get an 8 there, so 2 goes into 18 9 times, and that is how much it goes in evenly, 99 times. So I'm going to erase this, and I'm going to put the 99 that we just got from dividing right here, because 2 times 99 makes 198. Now, I know I don't have the divisibility rule for 11, but I know whenever 2 numbers repeat like that, that was divisible by 11. And I see 11 as in my prime number list. So I'm going to put 11 here, even though I don't have that rule written down. We should know that anytime we see a number that's doubled up like that, it's divisible by 11. And we should also recognize it's going to be 11 times 9. Now, one of the mistakes that people were making on the book widget on Friday was they were thinking that 9 was a prime number. But look at the list of prime numbers real quick. 2, 3, 5, 7, 11. 9 is not prime. And the reason why 9 is not prime is because it can be made by doing 3 times 3. So when we write our prime factorization, I'm going to go from the smallest of these prime numbers, the ones that are not branching apart, and I'm going to write 2 times 3 times 3 times 11, and that's the prime factorization of 198. Again, if you want to check, you can always multiply the numbers together. 2 times 3 is 6. 6 times 3 is 18. 18 times 11 is 198. Okay, so that was factor trees. Now let's look at the ladder diagram. Ladder diagrams work a lot like the factor trees, where you can only use prime numbers for the sections out here. These numbers out here have to be filled in with prime numbers. I'm not making zeros there, I'm making blanks. And then it's always going to finish with a 1 at the end. The 1 at the end tells you whenever you're done. So I'm just going to back up, take off those empty spaces, and let's go through the visibility rules and our prime numbers to figure out what is the first number we should work with. Again, if it's not obvious to me, I like to work from the low numbers up. So 2 does not go into 99 because it is not even, it's odd. It ends with a 9. So then I can check for 3. I know the 3 goes into 9, and I know the 3 will go into the other 9. So I'm very, very confident with putting a 3 there. And if you don't know how many times it goes in, 3 fits into 9 3 times, which is 9. Bring down the 9. It's going to go in 3 more times. So it goes in evenly 33 times. Okay, I see 2 3s there. By the way, the answer to that goes right here. 3 fits into 39 33 times. So I see 2 3s, so right away I know it's going to be divisible by 3 again, and that goes in 11 times. Now, once you get to this point, this is an important point right here. Right here, it's very important that you recognize that that is a prime number from over here on the list. 11 is prime. So because that's prime, that's where we know that we are going to divide it by itself. The last rung right here is always going to be the prime number dividing into a prime number, and that's how you get 1 at the bottom. So the prime numbers, don't forget, are all these numbers out here, the 3, and the 11. 1 is not prime. It's not on our prime list. So those are the numbers that I'm going to use to write my prime factorization. Because remember, prime factorization can only use prime numbers. So 3 times 3 times 11, the 3 numbers that are right here. And that is the prime factorization for 99. Oops, for 99. Okay, so we're going to do one more together just to get one more look at it. So 530. So a lot of people get really scared when they see big numbers like this, but there's no reason to get scared like that. So again, start small, work your way big. So the first thing I notice is that it is even. It ends with a 0. Now, I know that I have a divisibility rule for 10 that says 10 goes into anything that's 0, but remember, 10 is not prime, so we can't use it on this problem. We can only use prime numbers for dividing. So we're going to start off with dividing this by 2. So off to the side, I'm going to split this number in half by dividing by 2. 2 fits into 5 twice, which is 4. I get a 1 when I subtract. I drop down my 3. 2 fits into 13 6 times because 6 2s are 12. Subtract, I get 1, drop down to 0. 2 fits into 10 5 times, and that is 10. I have no remainder, so that's me going into the number evenly 265 times. So remember that 265 that we just got goes right here, 265. 5. So now I look at 265. Again, it's not even now. Now I check for 3. 2 plus 6 is 8. 8 plus 5 is 13. 3 does not go into 15. Or 13, I'm sorry. 2 plus 6 is 8. 8 plus 5 is 13. 3 does not go into 13, so 3 does not go into 265. 4 needs it to be even, but we have the 5 rule. And 5 is a prime number. It's on my list. I don't even know why I was checking for 4. 4 is not prime. But 5 is prime, and it does have a rule, and this number does end with a 5. So we are going to divide this by 5. So how many times does it fit into 265? Well, 5 doesn't fit into 2. It fits into 26. Oh, wait, I made a mistake there. It fits into 26 5 times, not 4. Because 5, 10, 15, 20, 25. Okay, 5 times 5 is 25. I subtract, I get 1. Drop the 5, makes 15. 5 goes into 15 3 times, which gives me 15. I get 0. I put the 53 in here that I just got. And now, as you notice, I don't have any more spaces on here. Now, I'm giving you how many spaces there should be, but it doesn't mean that the problem has to tell you how many spaces there are. But at this point, when I get to 53, I would look over on my prime list because 53 is a weird looking number that doesn't look like it should be able to be split up. And when I look on my prime number, I see that there's a 53 in the list. 53 is a prime number. Remember, once we get down to this step where we have a prime number in here, we divide it by itself, and that's what gives us the 1 on the bottom. So the prime factorization for 530 is 2 times 5 times 53. And really, if you think about it, that really makes sense because 2 times 5 is 10, and 10 times 53, that's 530. So it definitely makes sense. So the prime factorization is 2 times 5 times 53. Well, I hope that this review helped you out. Make sure that you're using that info sheet while you're doing the work, so that way you know what numbers are prime and what numbers are not when you're doing these prime factorizations. Okay, so good luck, and I'll see you on Google Meets.